Okay. Okay. So this is part two of friction. Right, part two of friction. So let's attempt it. Why don't we? Let us attempt it. I'm actually gonna redo this. Redo this. I'm gonna take this. All right. Okay. So we got right. We got a 70 kilogram skier. So we got a 70 kilogram skier. Actually, let me. We got a 70 kilogram skier. And that's his mass. So the skier slide has on wax skis, right? So on wax skis on a horizontal surface of snow. And if you look at your approximate coefficients of friction, you'll see that you have wax skis on snow. Well, are we dealing with kinetic friction here, or are we dealing with static friction? Well, yes, we are. We are dealing with kinetic friction because we clearly see that the skier here is moving at a constant velocity. And so we're dealing with kinetic coefficient of friction. And so wax skis on snow gets you 0.05. And so the question then becomes, right, so it's moving at constant velocity. So the question then becomes, well, what is the horizontal force moving him forward, right? What is this applied force? Right, so what is his applied force here? Right, they want to know, well, what is the applied force moving him forward? But here's an assumption you have to make, right? Here are things you have to make. But if you're moving at a constant velocity, well, something is equal to one another. Go to friction, go to values, and then speed. Alright, and so let's go here. And then we move this, and you see that, well, you're moving, and your object is moving, and you have a greater force than your force due to friction. And so we can see that clearly if you look at my speed, right? If you look at my speed meter, my speed is constantly changing, right? It's changing, it's increasing. And for me to get an object moving at a constant velocity, well, what must happen? What must happen? Well, for you to move at a constant velocity, well, your applied force must equal to your force due to friction, right? And so your speed here is constant when your applied force is equal to your force due to friction. And I can prove it another way, right? I can prove it another way. So the simulation is there, and so hopefully you get it. But additionally, I can prove it another way, right? I can prove it like this. And so if you're moving at a constant velocity, you're moving at a constant velocity. If you're moving at a constant velocity, your acceleration is 0. And if you're moving at a constant velocity, well, F net is equal to ma. And so this is Newton's second law of motion, right? And so, well, if your acceleration here is 0, well, mass times 0 gives you 0. And so your F net here is 0. Right, that's your net force. So your net force here is 0. Well, what are the two forces acting in the x direction? Well, there's an applied force. There's an applied force. And there is a force due to friction. Well, in your net force is the sum of all your forces. That is the definition of your net force. Right, this is something talked about in lesson 4.2. Well, if F net is the sum of all your forces, well, then that must mean the only forces acting in the x direction are applied force and your frictional force. So we're going to do applied force minus your force through friction. That's going to give you 0. Well, why is my force through friction here negative? Why is there a negative sign? You thought I just said is the sum of all your forces. Well, your sign here is negative because your force due to friction is acting in the opposite direction here. right? And that's why we're subtracting your force due to friction. You're subtracting your force due to friction because, well, it's acting in the opposite direction. And if we continue with this proof, right, so we're going to do this, force applied is equal to your force due to friction, right? And so we can say that, well, if we're looking for our applied force, well, we know our force applied is equal to my force due to friction, and which also means, well, then I am solving for my force due to friction. And so let's do that. My force due to friction is equal to mu Fn. Force due to friction is, when we're solving, so mu is 0.05. But we also learned in the last video that, well, you know that Fn is equal to Fg. And I'm not going to prove this. I already proved this in the previous video. I'm not going to prove it again. And so Fn is equal to Fg, your force due to gravity. But we don't know what our force due to gravity is. But we do know that our force due to gravity is equal to mass times g. Right? It's equal to mass times gravity. It's weird. I'm running out of space. Equal to mass times gravity. Alright, and so your force due to friction is 0.05. Mass is 70. And then g is 9.8, right? That's your acceleration due to gravity. And so you solve this and you plug into a calculator. You plug into a calculator and you get 34.3. 34.3 newtons. Alright, and that is your answer. That is your horizontal force pushing it forward, right? Because it's equal and opposite. Alright, so with this problem, they're looking for your minimum horizontal force, right? They're looking for force applied. Alright, so they're looking for force applied. Needed to start a 700 Newton steel block. And so they're right here, they're referencing your force due to gravity. Because the 700 Newton steel block, that's your weight. Right, that is your weight. And so it's a steel block on the steel table. And so the question is saying, well, what's the horizontal force needed to start this steel block in motion? So this steel block has not moved yet. Right, the steel block has not moved yet, so we are dealing with static friction here. Right, we are dealing with static friction. So, well, it's a steel on steel table. And so you look down here on your coefficient of static friction, right? And you should see 0.74, right? So steel on steel. And so the coefficient of static friction for steel on steel, right? For steel on steel is 0.74. All right. And so again, this was proven in lesson in the previous video in 3A. So our force applied here is equal to our force due to friction, right? That's just something you need to remember. You don't have to remember the proof. You just need to remember that it is equal to each other. And then we have the formula. Force due to friction is equal to mu Fn, right? And so then we have force due to friction is equal to mu 0.74. We also know, and I'm not going to prove it again, we also know that Fn is equal to Fg is equal to mg. Right? And this is just something you have to remember. So your normal force is equal to your force due to gravity. So 0.74 force due to gravity, that's 700. And then you get 518 newtons. And that's what you should get. You should get a force due to friction of 518 newtons. So we're going to do 3D now. So you have a 420 kilogram puck, right? So that's your mass, 4.20 2 kg. And you're slow to rest, so the object is moving, right? It's being slow to rest, so the object is actually moving by a frictional force of 7.8 newtons. So the question says, well, what is the coefficient of kinetic friction between the puck and the surface of board court? So what is mu? What's mu k, right? Kinetic coefficient of friction. And so we're going to set up our equation again. Your force through your friction is equal to mu Fn. And so your force through friction here is 7.8 mu k Fn. And so your force, your normal force is equal to your force through gravity, right? That's something you have to remember. This is equal to what is it equal to actually? Mg, right? Mg. So it's equal to mg. Right? So you have 7.8 is equal to mu. Fg is mg. And so we keep substituting. Mass is 4.2. G is 9.8. Right, G is 9.8. So now 4.2 times 9.8 gives you 41.16. You divide by 41.16 on both sides. And you get what did you get actually? 7.8 divided by 41.16 gets you 1.9. 0.19. And that's your mu. That's coefficient of friction. I actually am curious. This is kinda. I want my size increase that. That's good. That's better. Okay. Move on to 3E. Jill is pulling on a 600 Newton sled, right? So you have a force through gravity, right? That sled is 600 Newtons. A force through gravity is 600 Newtons through the sled at a constant velocity, right? So it's moving at constant velocity, using a horizontal force of 35 Newtons. So your horizontal force here, your applied force here is 35 Newtons. And so the question says, well, what is the kinetic coefficient of friction of the sled on the snow? Right, so what is your coefficient of friction? You're going to set up your friction formula. You know that your applied force is equal to your force through the friction, right? That's just something we know. I proved it. If you don't remember the proof, that's fine, because the only thing you need to remember is that it does equal to each other. Same thing with your normal force. Your normal force is equal to your force due to gravity. And so we're going to replace that with that. And so your force due to friction is 35 newtons, right? Because your force due to friction is equal to your applied force. And your applied force is equal to 35 newtons. And then mu, your force due to gravity, 600. Divided by 600. So you have 0.06, and that is mu. All right. Okay. So this question, so a 50 Newton force is applied to an 8 kilogram box. So you have a 50 Newton force applied to an 8 kilogram box. Right? You move at a constant velocity of 8 meters per second. This velocity is not necessary. You don't need it. Right? You don't need it. And the question says, well, determine the magnitude of the force due to friction acting on the box. Right, so as your force due to friction, well, if you're moving at a constant velocity, you should know that your applied force is equal to your force due to friction. Right, and so your force due to friction here is 50 newtons. And that's the answer. So for B, says you have a 10 kilogram box, right? So you have a 10 kilogram box. The box is acted on by a force of 47 newtons east. So that's your applied force. And a frictional force of 17 newtons west. And so this is east. And this is 17 newtons west. What is the magnitude of the acceleration of the box? So acceleration is so you're gonna set up your equation, right? F net is equal to ma. That's Newton's second law. Newton's second law is a is equal to F net over m. But if you multiply by m on both sides, well, you get F net is equal to ma. So F net here is the sum of all your forces. There are only two forces acting in the x direction here. And that is your applied force and your force due to friction. Those are the sum of all your forces. So your applied force minus your force due to friction. Again, you're subtracting because it's negative. It's going the opposite direction. So 10A, so your force applied, 47 newtons, minus 17. So 30 is equal to 10A. A. Alright, and then you get this. Alright, and that's it. That's it.